So here is my model. It's pretty much the pretty reasonable replication of the chameleon. Now this is not for sale. This one right here is this is nothing that I'm actually trying to sell. I would never, even outside of legal rules, I would never blatantly rip off somebody's thing. It's not right to do it. It's not fair to the other person, and it's kind of a sign of your own weaknesses, I guess you'd say. It's like you suck so bad you couldn't come up with your own thing, right? Or you're too lazy, or you didn't want to spend the time to figure it out. You want to rush it out. But what I do like, I actually enjoy this. It takes sometimes hours to get it right, but reverse engineering a product, anything. If I'm looking around here, on the bench, I don't know, here's some, right? Reverse engineer something like this, as exact as you possibly can. In the course of doing that, you're going to find out a lot of interesting things, like how the designer originally designed themselves. And as you do more and more products, you'll start to find, that there's commonalities between designers, things that they do fairly regularly. One thing I was talking about the other day was whether or not, like, you should just do this as a spline, right? A lot of people would do that, but I almost find never in any kind of production thing that's not artistic or something like that, do I find some kind of a spline curve. It's usually a 3-point arc, a 3-point arc, a 3-point arc, right? And so you'll start to figure things out like that. And then the other things, like in the sketch, do you do this whole shape, or do you decide to just do like an arc and leave this end right here sharp, and then you come back in later and you add fillets after the fact? Sometimes that's a little bit more smart. So anyways, I have this pretty decent replication of the armored chameleon right here, and then I can go about trying to figure out how I'm going to mill this out. Now, as I'm thinking about stuff like this, I think, first off, how can I do it, right? And again, when I'm, reverse engineering it, whatever the hell you want to call it, copying the thing, measuring it out. By the way, this is all pretty much done with calipers and a couple other tricks. When I'm doing this, I'm thinking, let's just get this job done, and then we'll figure out the rest of this after the fact. And then when you're doing it, when you start to lay it all out, and then you start looking at the tool paths, and you're thinking about the different tool changes that you're going to have to do, the different end mills that you're going to have that you may or may not have, and then, of course, the time that goes along with all of this, this is when the production brain should be kicking in here and going, you know what, I don't think I can do this. I mean, I think I can get it done, but this part that costs X amount of money is I'm never going to make any kind of margin on this, or I'm going to lose my ass completely, right? So you have to keep that in mind. And these are obvious things that people say all the time. If you look at, John Saunders and NYC CNC, and even Louis Rossman, and anybody that's got their own shop, that they're out there talking about how they do this stuff, and they have to pay the bills and maybe be able to go on a vacation every now and again. You can't just be working your ass off trying to sell quantities of parts that you're making 50 cents on. All right, so, but now having said all that, I will still plow through, I guess, if you will, and get a part done, and then determine after the fact if I can enhance, optimize the process. Okay, so that's what we're doing here today. So before everybody out there gives me a lot of grief on, hey, how come you didn't do it this way? How come you didn't do it that way? I'm probably aware of a lot of those, right? And if it was going into production, I might do other things differently. Like, for example, here on the screen, if I look at this, as I showed before, these different parts here are massively, different thicknesses, right? So these things are different thicknesses here and here, and this wouldn't make sense in production to put these all out of one plate, because what's going to happen in the cam side of things is I'm going to have to actually mill away all that carbon. And then maybe secondarily, or possibly even primary if it's that big of a concern, the fibers are going to be all broke over the top there, and I'm going to have to sand it possibly. I'm not going to get a good finish out of it, and that might not be aesthetically pleasing, and aesthetics might actually be a thing that is selling your product, so that might not be able to happen. But anyways, again, in this product right here, I'm going to cut it all out of one sheet just to see if I can put it together, if it works. I'm also mildly curious, because I haven't done this before, milling out carbon fiber down to a certain level and seeing what it looks like. I have a few different things that I want to see about this, which have nothing to do with production. Okay? Then I'll get it done, and then after that, if I think that it's pretty cool, and if I decide to sell some of these, if some people hit me up and say, hey, that's pretty cool, could you make me a 6-inch one? Could you make the angle be a little bit, you know, steeper, deeper, tinier, whatever, you know, I'd like to have a bigger motor. Could you make me a different base for that? Would you like to have a different hole pattern, right? After that, if we get that far, right, then you start doing other things. Like, for example, the thing we're going to lay up today is it's basically going to be about 12-inch, 14-inch or so square, and we're going to pull this out of this. In the future, we would take just this base right here, probably again put this in Fusion and just make mega copies of these, however many I feel is reasonable, and start trying to fit these together in whatever optimal way is going to, you know, save me money on, you know, materials. Because as you could imagine, at around $50 a yard, linear yard, carbon fiber, half, you know, 4 or 5 millimeters thick, it's going to cost a fair amount just right here. You know, I figure just the cost of a 12 by 12 frame, you know, we probably have, gosh, you know, unless you get a good deal on it, it's almost, you know, not good right there, you know, because I think we're probably spending $100 just in carbon fiber. So you better figure out a way to optimize this. So somewhere down the road, then yeah, maybe I go about that. You know, maybe we make one long rectangle that's all just base plates, and then we lay up another one that for the 2 millimeter parts, and then we make a crap ton out of that. That can probably, you know, begin to start making you some money. All right, so look at the tree here. This, I just want to point out a couple things. The model in itself is, I don't want to say no big deal. You know, it takes some time to figure out how to effectively rebuild something or build something from somebody else's design. So that's you know, no small thing in itself, right? You should practice this. The thing to pay attention to, though, is this right here is an assembly. Those of you coming from different programs, this is Fusion 360 Inventor is designed in such a way that we can make this be just a single part, or it can be assembly. It's kind of either or. So right up here at the top is your initial container, if you will, right? It's your component. But in your component, you can have other components, let's say, right? And so here, this component, rather than just building one thing into it, what I have done is I've created things like, for example, the base frame right here. Here's the thing called the top, and then here's the thing called the cam base, and here's the cam side plates, right? Whatever you want to call them. But these are now separate. Now, my point is that in the beginning, when you first start doing this, it's probably okay, or a good thing, or maybe even wise, to put it all together and just do it together with everything else, because you're trying to, a lot of times, you know, the word for this is relational design. We're trying to build one thing off of the other one being visible, right? We like it to be visible so we can kind of see how they relate to each other. Anyways, ultimately though, what you want to do is after you've done this, keep this in mind. When you're done with these parts, make sure that you save a copy, right? If you save a copy, here's kind of the process. You save a copy as, and what's this? This is going to be the top thing here. I probably don't want to do this right now because it'll screw up my joints. What the hell, whatever. So I save a copy as, and I save it into, you know, the file online. And actually, I'm not going to do it. You'll save it in there, and then you delete this when you drag it in. So the point being, you will end up with a link. This will be a link to another product, another part somewhere, and the benefit there is that if I want to use this piece in a different model, I can take it. It's not contained up inside of this one here. And that's pretty much the critical deal right there, right? You can tell that it's a link because it has a link symbol on it. All right, I'll go ahead and do this. So I'll just, I'll pick this cam base right here. So we take it, save a copy as, make sure it's going in my chameleon one here. Now this is the name of the whole entire thing up here, so you don't want to call it that part, just call it cam base. This is a stupid name. This might not be what you want to call it. You know, you want to have something more informative. If you think you're going to change it, always put some numbers after it. I'm going to leave it as is for right now. Hit save, and it should, down here, you can see it dinking around. And then over here, you're going to have your cam base show up. At this point in time, the cam base, the original one, is still just hanging out here. Make sure that you handle this, because having two of the same parts in separate locations is always a bad thing, because you never know which one is the newest one, and more than that, you end up having one that was changed, so it's newer, but then over here you change this one too, but it's a different change, and then you change this one and you never really know which one's which, or which change is which. Okay, so I don't see it showing up there yet, but it will in a second. So what you want to do is you get rid of this now, which is a little bit scary. You're like, oh God, I don't know if I want to delete it. Get rid of that, and then you could drag your cam base in here, and it should plop in here. It's thinking down here as a new component. So there we go. So here's our new component in here, known as cam base, and I will jangle this up here. You don't have to. You can do this, of course, with your joints, which is probably a better way. This is just to get it out of the mess that might be, you know, all the other parts. So I put it there, and then here's the big point. Right over here, you'll see the link. So this part right here is a link to something else. That's good. That's what you want to have. All right, another thing, I wasn't going to show this. I was just going to go ahead and just fix it and do it, but I thought I'd mention this. Most of you probably know, whatever, you have a base frame in here, you have one object and you ground it. In CATIA, it would be the same as anchoring one particular assembly. So you have one piece that makes sense, usually, hopefully, that you lock. It can't move. And then everything else comes to it, right? So this little story is, take this and you lock this somehow to this. Okay, and then you take another thing and you want that to be locked to this as well, but you say, well, hey, this thing's sticking out right here, let's just lock to it because this face is on that face and they should go together. There might be a case for that. It's probably, well, think about it. That's maybe the point, right? In this case here, everything links to the grounded part. So all of these parts here, this face right here is linked planar to the bottom of this frame, the frame here which is grounded. This is stuck to the bottom of that. Well, it's the same part as that, but it's stuck to the bottom. So I do not want to take this piece right here, this face, and stick it to the bottom of this, even though the bottom of that is the same as the bottom of that, which is the same as the bottom of that. You want everything linked from the main. Make sure that you're up in the root assembly, if you will, if you want to call it that, and we're going to stick one of these things to one of these things. So this is going to be not rigid. We're going to make a planar joint here. Think about this. All these parts here, they're all just flat patterns. It's as in, like, if I flip this over, there's no difference between, you know, right side up, upside down. But if there was, make sure you're conscious of that. So I say, all right, I want this face here to be planar with this face over here, and almost every single time, I think every single time it does it, what it's going to do is it's going to take those two faces and want to stick them together, and that's not really what we want to have. So just know that you'll say planar, it will go like this, and then make sure you hit the flip button, which will flip it up inside the other part, and then we can move around from there. So planar, pick here, and then pick this component there, good. Pick again, it will do its little whoop-de-woo and come over here and show you that that's where it's going to go. And as you can see, it's down here on the bottom. So hit flip, flips it up inside of it. That's good. If you want to move it at this point in time, you can, or just come out here and grab it and move it after the fact. Now this one, I am not super duper worried about its placement. Later, maybe for optimization or something, you might want to do some other kind of constraint on here to get it exact. I'm just going to go and put them in place here. When you're placing parts here to be cut out, know that when you place them, you're going to, in a lot of cases like this, we're going to leave some tabs behind so it just doesn't jump out and get all damaged, right? If you're using a vacuum table, if you make a really specific vacuum table that this won't release the vacuum and jump out of anyways, then you don't have to do that. So keep that in mind. That's a cool thing to do. That'll probably be a different video. Anyways, this, you have the tabs and you have the end mill that you're gonna use to cut it out. What I'm getting to is make sure you leave the space for the end mill to come around here to have clearance. So like right here, this is probably not good enough. And you would say, well, yeah, it looks fine to me. I mean, if we're making all these tiny little holes, sure, we got enough room there. Cutting out a profile with a 1/16 of an inch end mill or a millimeter or 2 millimeter end mill is not going to work out well. So what we're probably going to want to do, I could probably even imagine that right here is not good enough. I'm going to cut this out with a 1/4 inch. One of the reasons is, one, because it's a better tool. I could probably do it with an 1/8 of an inch. It'd probably be just fine, but I know I can go faster with a 1/4 inch because it's a lot more durable. But also, since we have the different height right here, and I'm going to have to mill down to face this down until I get to the right thickness, I'm going to be using the 1/4 inch end mill anyways, so why not use that to profile cut after I'm done with all of this stuff. So, having said that, I'm going to grab this and I'm going to nudge that up just a little bit, and I'm going to nudge this up a little bit. The piece that I have out there that we made is about 14 or so inches square, so I know that I'm okay here. In the future, you would want to pull this in as tight as you could possibly get it to make sure that you're optimizing for space, of course. All right, so there is my part. I don't think there's anything else to go with this, but I will show you this. So over here, I have my boundary, a couple different things I've done. Here is this neat little trick. There's the picture. I go online, find a picture of a chameleon, and I can try to copy it. I did this prior to me getting this to where I could go off of that, right? So I was just excited. So I was like, let's do the best we can. You can never really get a picture online that's at the right perspective, but I figured at least I could use it, and it got me close, at least the right shape and such, right? So that's kind of neat. That's always a good trick. So this is a canvas. Go research that. John, just the other day, NYC CNC put out an awesome video showing that. He's got another one that he did from, I don't know, maybe about a year ago on there on his Fusion Fridays, so check that out. The other thing that's similar is this. You can take this part right here and just put it right up against the screen and check it out. So let me move you around here. So this is going to be wacky. So here we go. So I'll try to keep you still here, and we put this right up there. Look at that. Now, of course, zooming in and out becomes kind of a challenge, right? But you can use that as a guideline as well. Sometimes I've literally taped this to the screen so you could move around better. On bigger parts, you can just set it down here, like this. There. So is this a perfect copy of an Armaton chameleon? No, not really. So it's helpful to use the shift zoom so that you can get it to be, reasonably the exact size. So how about that? So that's pretty good. As you can see, a couple different differences here. I haven't put this together yet, so I'm not exactly certain why these holes need to be exactly the way they are. Do they need to be that way because certain things are fitting through? I guess I'll find that out later. That's another point to these videos to this video, is that I don't really care, right? So before you get on me about, this isn't right for this quad and don't you know this? Well, no, I don't. Sorry. But I'm going to figure it out and I'll find it out later. So here's the cam file. Let me go through what I got here. I basically have 4 operations. What I'm going to do is I'm going to cut out all the small holes with a 1/16 of an inch end mill. Then I'm going to switch over to an 1/8 of an inch end mill and cut out all the holes, all the larger cavities. Then I'm going to an adaptive with a 1/4 inch to remove all the material off the top of these thinner parts. And then lastly, the profile passes to cut this out. Alright, so I have centered it, indexed the whole thing, and double checked my thickness, because one thing I forgot, or at least I forgot if I remembered it earlier or not, is the stock thickness, the thickness of the model part that I made. Was it truly the thickness of this material, or was it the thickness of the Armaton, or was it some thickness that I presumed that it was going to be, right? Or like I looked at it from the documentation online. Turns out it's pretty close. So this measures out, it was like, I don't know, 0.1967, something like that this was. And that was, again, like I said, pretty close, but all the same, prior to the last posting of all this stuff there, what I did is I ran back in and I told all of the hole drillings and the profile cutting to go another 20 thou through. Okay, it changes a little bit of the height of the tabs, but that's not going to be a problem. But just to make sure that I get this one through so I can validate, verify what this one is. As again, you iterate this, everything along the way, all your quality steps, all your checks from the composite buildup, the stack up, the compression molding, the pressure that you're putting in under the vacuum bag pressure, whatever else will be standardized so that you know that you come out with a reasonable thickness every single time and you know what that is. All right, I've loaded up the second pass. We have a thing that looks like that. Okay, let it rip. So far, I have to say that this is looking pretty good. Let's see here, let me back the zoom up here a little bit. All the holes look like holes. I don't see any breakout whatsoever. Inside there, the layers look good. This is one thing I was worried about. So in the composite video, when I'm putting this all together, it is really sloppy. So if there's anything, some people might say, oh my god, you're using way too much resin, right? But oh, there's a little bit of some fuzz right there. I was always whatever worried that I'm gonna have not enough resin inside there, or I'm gonna have some dry spots. You know, you can have something like a really nice looking plate and it looks fine on the outside, and you start cutting through and milling into it, and all of a sudden you start getting a whole lot of fuzziness because it's the dry fiber inside of there. So far looking good. So next up is the well, it's the two passes. It is the adaptive clearing pass, where we're gonna shave down these layers so hopefully what they're supposed to be, and then the profile pass where we actually cut it out. Yay! All right, we're now on pass number 3, and it is gonna look like this. So there is the adaptive, and there's our profile. So we saw this in the beginning, right? Cuts around and then layers down, cutting it all out. So that's it, we're almost done. Crossing my fingers. So far pretty good. So this one's supposedly going to be going at 80 inches a minute. I have it on a speed control over here in case it gets a little bit hectic. I'm sure it can cut it, I just don't want it to cut it and cause it to fray too bad. In most things we do, we use high speed, like with the die grinders and such. Anytime we're cutting anything fibrous, we want massive high speed and just annihilating the thing. Of course, limits, you know, but that's the idea. Wow. I do believe that this finished fairly uneventful. Look at that. Interesting. All right, so let's go get this out at the table and polish it up and see how it looks. See if it matches. All right, well, looking here, the frame itself looks really nice. Right in here, a fair amount of fuzz, but as long as I don't pick it back, I should be able to sand the front of the face of that once I pull it out of here, and then round the edges, and it should be fine. Same up there. A little bit hairy, not much edge margin, but that's the, that's the way the original one is. Cool. Let's compare. Right, so I copied for the most part, all the stuff that I thought was going to matter, negated a few things like I don't know if these bumps are critical yet or not, and some of the shape I took some liberties with. This shape, it's kind of a straight and then a kink and a kink and a kink, and so this is all fairly continuous now, but let's take a look. Whoa. Not too bad. Wow. Yeah, that's actually... You see the holes there? This is a really shitty way to be holding this thing here. But I think the holes are in. I think I've nailed every single one of them, like spot on. Huh. That's always really cool. Little bit of, I don't want to say guessing, but you have the picture to kind of go off of. You get the original. You start making your measurements. You start placing things. Like, by the way, notice that even the motor holes here line up, right? And that's a big feature. So you're thinking, yeah, big deal, right? Except, well, they go at the right angle. I didn't look at that at all. I just assumed that whoever the designer would be would have a line coming down through the middle here as kind of like a guideline, that you use. I didn't show you that in Fusion, actually, by the way, that there's a whole construction line set that I made first. Let me pull this back a little bit. There's a whole construction line kind of body, if you will, or component that I made that had all the stuff that I thought was critical, and then I end up snapping to that. So for example, you could have your X's here or whatever you want, and then you could have your angle separation right here. And then I even included a thing that I'll show you later, because after I get done with this and it's all put together, we do some kind of crap with it and we see how it flies, we might use this as a way to talk about what to do next. Because of the different angle here, you get more or less, pitch and roll, depending upon what you want, of course, right? But the other thing I noticed is when you start putting construction circles around here to denote the propellers that you're going to have on here, you start to find out that these propellers here start getting really close in this area here and not so much up here. And that would be something that you'd want to know when you're designing this, right? So you put that in as construction line, because of course, you'd hate to get this far here, put all your props on and have them just whacking together. So no good there. But anyways, hot damn, I'm pretty thrilled that that works right. Looks good. So that's great. How do we do on the other ones? So this one here, let's see what we did. Oh, well, look at that. Forgot some fucking lines or some holes. So that's a dumb. Okay, so there's some missing holes there. But the rest, holy shit. The rest line up pretty good. What's going on here? Oh, I got it flipped around. Hold on, come here. Okay. God damn. Pretty good. Okay, 2 for 2. The next easiest one, this guy right here. It's got a bunch of crap all over it. As far as I can tell, holes right on through. Oh yeah. Okay, good. This stupid little bastage. This was the hardest one of the bunch because there's nothing really to key off of when you were designing it. Like this square, you just measure it and you say, okay, how far, how wide, how this, and then once you get your square, then you can say, bring this in so far from an edge, so far. It's easy to get a caliper on an edge right here and measure it to see how far in it is or what have you, right? This thing, I had nothing. So what I chose to do, I stared at this for quite a time, and then I thought, okay, well, here, let's do this. What's critical about this? This isn't critical, this isn't critical. These holes, these are the critical here. So I, again, did a construction component, and I just made a triangle, and I tried to figure out what this triangle might be. And so that one was tough. Again, playing with the length, I can get the lengths of the holes from center to center as best I can figure out, you know, so I try to figure that out. And you get, again, a weird dimension, but I mean, you're measuring with a caliper, and you're trying to get down to like, you know, 1/1000th of an inch or less or something like this. And again, this is metric, so you're working with that. And, you know, you could be off by, you know, whatever, a fraction of a millimeter or something like that, just because you're holding the calipers funny. So you don't really know, is it actually 33 millimeters, or is it really 33.459438, whatever, but this angle right here is 45 degrees. So that was a little bit of a disaster, a mess. So let's see how we did here. And then of course the hole in the middle, I know this to be a thing, critical feature, because this right here is pretty obviously, this is going to be the tilt mechanism, you know, like an old school alternator for the setup for the camera. So I'd say I got it. I'd say I nailed the holes, but I can feel down here that might be fuzz, but I think the whole rest of the body is just a little bit oversized. And well, I don't know, I gave that a little bit of leeway too, because this part here, I'm not really concerned with. I figured I might as well do it for due diligence, but again, I'm not really trying to copy exactly in entirety the Armaton Chameleon. I don't really give a shit about that. I'm not trying to steal their product. I just want to come up with a frame to make, and this one here works, so if I make all these parts and pieces and it goes together fine, then I know I got something. Most likely what's going to happen in the future, obviously this is going to happen in the future, I make all my own stuff all the time, right? This is going to end up being some custom design that we work on, us and some friends, and try to figure out, you know, what's going to be the best deal for this. So here's the final product. I think it came out looking pretty good. The things I like about it, I'm pretty happy with. I like the continuous curvature right here. Well, not exactly continuous, but it's not so jangly like the original Armaton was. So that's been smoothed out. I like the thinner arms. They came out a little bit thinner than the other, and so that's going to lessen some of the aerodynamic drag. It's maintaining about the same rigidity because the thickness is 5 millimeters instead of 4 millimeters. I like the radius, even though that takes a lot of extra time to do that. It's also going to create less aerodynamic drag, and it feels a lot better in the hand. So that's pretty good there too. The finish looks fine. You know, I wasn't going for super shiny, and it looks sufficient. It's flat. By the way, though, this is the plate that we made with the compression mold. The one with the vacuum bag ended up having, if you can see, like we've seen the other one with the compression mold, we had 2 plates on top, so we ended up with a nice finish on the top and the bottom. The one with the vacuum bag left a little bit of bumps on the top of the surface, right? It's potentially can be maybe a better product because the vacuum has the ability to suck out a lot more resin. Depends. No, you can always smash the crap out of it a lot more with the compression mold. But anyways, that's why I went with the compression mold here, is because we had a smoother finish on both sides. So let's see, what else about this? So I think that's basically it. We'll get this built up, and that'll be either in a different video or something else, like maybe the Instagram account that I'll tell you about in a second. And I think the thing that I want to play with the most is changing up how I place the flight controllers and all of, you know, the receivers and things like that. How I come up with my own unique mount for, say, the FPV cam. Things like that. I think that's where the uniqueness is going to come in this. I think as far as a quadcopter, arms, you know, motors, that's pretty much standard. So that is it for this video with the copter. The thing I want to mention though is I did start up a brand new Instagram account just for this, and kind of aggregating some of the other accounts of different things I had around. So I show things like, for example, look at this cute little baby snowboard I made. So I did this the other day, UHMW plastic, just like the real deal, carbon fiber top, even made the little holes, cut it out on the CNC. But, you know, it's not worthy of a video, so we snapped some pictures of it, and that goes on the Instagram account. Things like this. This is my, one of the little drive brains for one of the robots that I did. That sort of thing. So that's the kind of stuff I throw up there, the day-to-day happenings, you know, what's going on with me and my life and all that jazz. So anyways, that is it. Thanks everybody for watching.